How many times do you think you've used engineering drawings so far today? Well, more than you might think. If you rode on a bus, if you rode in a car, if you walked with shoes that were made in some machine, you've used engineering drawings. Indirectly, but without engineering drawings, none of those things could exist. Engineering drawings provide the communication language for manufacturing and for industry. And without those engineering drawings, we could not have buses or cars or machines to make shoes. The fundamentals have not changed, even though we're using computers as electric pencils to help us make those engineering drawings. Well, in this series of tapes, we're going to introduce you to the fundamentals of making engineering drawings. In today's session, we'll introduce some of the basic manual drawing tools. And if you build a little bit of skill using these tools, you'll be well on your way to becoming an expert in making engineering drawings. We'll start our discussion of drawing instruments with the pencil. There are two basic pencil point styles used in technical drawing. One is the conical point, the other is the blunt point. A little later we'll discuss the actual holder that's holding the lead that forms the point. Also, we'll be discussing the different types of lead found in drawing pencils. We have different grades of lead, starting with the hard lead. Hard leads are used for construction lines and for light lines, and they vary from 9H, which is the very hardest, down to 4H, which is not as hard as 9H. Then we have the medium soft degrees of lead. The medium soft degrees are used for object lines, which form the boundary lines for the mechanical objects that we draw, and they're used for dark lines. The medium soft range in designation from 3H, which is the hardest of the medium, down to B, which is the softest of the medium. The very soft leads are used for sketching and for shading, and they range in degrees from 2B to the very softest, which is 7B. Now, most typically in the engineering drawing business, drafters will use a 6H or a 4H for their construction or their very thin lines, and they'll commonly use a 2H for their object lines. Now, in some cases, depending on the medium you're drawing on, whether you're drawing on a particular kind of paper or whether you're drawing on mylar, you may change the degree of lead for your object lines or for your construction lines slightly. If you're doing a lot of sketching or artistic things, then you'll consider using the softer leads. Now let's take a look at some of the different lead holders. The type of pencils you see here are wooden pencils, and they're very similar to the pencils you've been using since grade school. You sharpen these up and expose the lead. Now, one thing that's different about the technical pencils is that on the very end here, let me slide this over so that you can see the very end, you can see a designation of the hardness of the different pencils. And as we discussed earlier, we can have everything from a 9H very hard lead to an F or a B or an HB, which is much softer. One other difference between these technical wooden pencils and the pencils you probably used in kindergarten is that we may sometimes sharpen these with a blunt point and then use a pencil pointer to put a particular style of point at the end of the lead. Next, we'll take a look at the mechanical lead holders. Mechanical lead holders are very similar to wooden pencils with one big difference. With a wooden pencil, every time you want to expose some additional lead, you have to sharpen it. With a mechanical lead holder, what you do to expose additional lead is you push in a spring-loaded button at one end, and then you can expose more lead. And you can adjust that. So now you don't have any wood to throw away. And you will expose just the amount of lead that you need, and then you'll use a pencil pointer to put the appropriate style of point on the end. The last style of pencil that we'll discuss is the uniform thickness lead holder. This is different than the mechanical lead holder in that we never sharpen the points on these pencils. Each one of these pencils has a special thickness of lead, And as you'll see when we draw with these pencils a little bit later, that we use a completely different style of drawing and we make lines exactly the width of the lead in this pencil. Let's get a little closer to the end of this so you can see what that looks like. This particular uniform thickness lead pencil has a 0.9 millimeter thickness lead. And on one end is a button that I can push to extend more lead, and on the other end is the lead itself. And I'm going to push the button and watch what happens here. Each time I click the button, you'll see the lead extends a little more. Now once again, with the uniform thickness lead holder, we never sharpen the lead. We use it exactly full width, and we'll be drawing with these pencils in just a little bit. There are a number of ways to put a point on a pencil, and this is especially important when we sharpen the pencil to the blunt point or when we use a mechanical lead holder. In the old days, you'd have seen people using a piece of sandpaper, and they'd very carefully turn and rub the pencil to sharpen it exactly to the shape they wanted. Sometimes they would sharpen it to a conical shape. Sometimes if they were doing a lot of long, thin lines, they might sharpen it to a wedge shape. More common, you'll see different kinds of pencil pointers. Here's one that we used to call a coffee grinder. What you do is you adjust the lead here until a certain amount is sticking it out. You put it in, and inside this device is a cone-shaped piece of sandpaper that as you go around and around will sharpen this to a very nice point. Now when you do that, it'll pick up a little bit of graphite dust, and that'll get on your drawing and make a mess. So we have this little ring of styrofoam here we can poke that lead into and clean all that graphite dust off. You also might use an old art gum eraser for that. A similar device for making points on a pencil is this lead pointer. This has an added feature. If I turn this just right, you might be able to see there are a couple of grooves here, each of which is a different length. And what we can do is we can adjust the length of the lead sticking out to one or the other of those grooves, and then when we place it in and sharpen it, it will get a different shape point depending on which of the grooves that we chose to use. Once again, this might be a little too sharp to use and it will have some graphite dust on it, an old drafter's trick. When you first sharpen it, you don't want that little sharp point breaking off when you start drawing, so just tap it a little bit and then poke it in an art gum eraser or this nice little cleaner that's provided here to clean that graphite powder off. Well, now that we've taken a look at the different types of pencils, it's time to make a few lines. I'm going to start by using the conical point lead holder, and I'm going to use a 45-degree triangle, and I'll just draw a few lines. Now, when you use a conical point lead, there's a particular technique that you need to use to keep your lines uniform. If you just hold the pencil straight and just keep drawing without moving the pencil, eventually you'll wear the lead to a funny shape and your lines will slowly get wider and wider. So the trick is, as you're drawing, you rotate the pencil at the same time, and that has the effect of keeping the lead sharp and keeping your lines uniform. So I'm going to just draw a few thin lines here, and I don't know if you can see that, but I'm twisting the pencil a little bit each time I draw a line, and that has the effect of keeping the line sharp. Now, these would be construction lines. Actually, they're a little darker than I normally would draw construction lines, but if I drew them the normal darkness for construction lines, you would not be able to see them on the display, on the video display. Now let me draw a few lines using the uniform thickness pencil. Now this particular pencil has a mark on here that says 0.7 millimeters thick, and the standard thickness for object lines is 0.7 millimeters. Now this requires a different technique than the conical point. Here I do not hold the pencil at an angle and I do not turn the pencil. Instead, I hold the pencil perpendicular to the paper and I draw firmly. I'm going to draw some dark lines, and I draw using the full width of that lead, and I use a lot of pressure for dark object lines. Now because this pencil has a nice 0.7 millimeter thickness, and because I'm using the full thickness of that lead, I never have to sharpen it, and I always get nice uniform lines. You might have noticed that I repeated. I went back and forth across there. Here's something that you might not realize until you get some experience, and that is, no matter how nice a drawing you make, no one will ever look at it. That seems silly at first, but what they will look at is a copy of your drawing. And unless you make nice dark lines with a lot of graphite on the paper, the lines will not make good copies and you'll be a failure. So always make nice dark lines when you're making your object lines. Let me make a couple of vertical lines here. And now let me make an angled line. I'm just fooling around here, but I want to show you a couple of things. Suppose I want to make an angled line and I want to stop exactly, whoops, I wanted to stop exactly at that horizontal line. Well, I did this on purpose because I want to show you erasing lines. And to erase lines, we don't want to use one of those old-fashioned pinky things that you used in grade school, but because they tend to smear, we want to use a special eraser for engineering drawing. This particular one is called a magic rub. There are other types of erasers that we could use, and some of them come in various styles. Here's a cylindrical type eraser in this eraser holder. Here's a similar one, a different color, and I can adjust how much sticks out. In all cases, I use this white plastic style eraser like the magic rub so that I don't put any smudges or smears of eraser on the drawing. Now, what I want to do is I want to erase just that little extra line sticking out, and if I try to do this, I won't be able to be careful enough to fail to erase the other line that I want to keep. So here comes something called an erasing shield. This erasing shield is a very thin piece of metal. It has so many holes that you're bound to find some hole that's just the right size, and you use it to protect the part of the drawing that you don't want to erase. Now, by erasing just the part in that hole, I can do precision erasing. I could erase this line right up next to that other line without hurting the other line if I was careful. Just clean this off. Now, you get some of this eraser dust on your drawing, and you'll want to whisk it off with one of these drafting brushes. By the way, this erasing shield, you might have noticed, has this one pattern of holes all the same size all the way across. Why would they put so many holes the same size, you might ask? Well, watch this trick. I'm going to line this up with one of my object lines. I'm going to rub pretty hard across there. Ta-da! Instant dash line. That's one way to make a nice uniform space dash line with hardly any trouble at all. One of the things you'll find that happens when you're using especially the 2H or the HB lead that's a little bit softer, and by the way, remember you need the softer or the medium soft lead to make these nice dark object lines. But what will happen when you draw with this and you press really hard, now I don't think the video camera is going to be close enough to show you this, but if we looked really, really close there, you would see some tiny, tiny little granules of carbon that broke off the edge of the lead. And if we allow those to lay on our paper, and then we slide the drawing instruments back and forth on those, pretty soon we'll make the background in the drawing a gray, muddy color. So we have a solution for that. We have just the thing here. It's called a dry cleaning pad. And let me open the box and get it out. And you'll see that there's this little baggie. And this little baggie is full of eraser dust. And what I do is I just massage it. Ooh, feels so good. I just massage it a little bit so that I get some of the eraser dust there. And then ever so lightly, I rub this across the drawing. And that picks up all those tiny particles of black graphite powder. And then I can use my drafting brush to brush that off. Now when I move the tools across, back and forth across the drawing, I won't be smudging it by rubbing those black particles of graphite into the drawing. So the erasing pad is very handy for cleaning up those little crumbs of graphite. But remember, they call it an erasing pad. Why? It's an eraser. So you don't want to overdo this. If you rub really hard for a long time, it'll erase your lines. So you just want to use a light touch and a little bit with the erasing pad to keep your drawing clean. Well, now that we've practiced making a few lines and we saw how to erase lines and use the dry cleaning pad to keep a drawing clean, now we're going to get a little more formal, and I'm going to take this pre-printed title block drawing form, and I'm going to tape it down to the drawing table. And I want to align it using the Tsquare. The Tsquare has this nice head and a very smooth straight edge, and just off camera when I slide this over, it's just going to slip over the edge of my drawing board, and then when I run it up and down, keeping the edge in contact with the side of the drawing board, I'll be able to make parallel horizontal lines. And I want to line the paper up with the top edge, or the horizontal edge, of the Tsquare. But I don't want to line the edge of the paper up, because after all, this pre-printed form was run off thousands at a time in a high-speed press, and the paper might have gotten cut a little crooked compared to the lines. What I really want to do is I want to line this up with the lines on the paper, not with the edge of the paper. So I'll very carefully adjust this until the top edge of the Tsquare is exactly aligned to one of the horizontal lines on the pre-printed form. Then I need to fasten the paper down to the drawing surface. And to do that, I do not want to use any standard masking tape or Scotch tape that you might find in the store, because that's not made to come off easily. And if you use that, you may tear the corners of your drawing. Instead, I'm going to use a special drafting tape. In this case, I'm going to use these special drafting tape dots that are available so that it makes it easier. And I'll just put one at each corner. This is like a little dispenser pack. When I pull on this thing a little bit, I pull on this tab, you see it sticks its tongue out at me, and I can take the next tape dot. And I'll apply one to each of the four corners of the drawing, with the drawing carefully aligned to that Tsquare, especially when I do the first two, because that will establish that the border of the drawing is aligned exactly to the Tsquare. Then I'm going to go back and I'm going to check it just to make sure that it hasn't slipped when I applied the tape. So using drafting tape or the self-adhesive tape dots, I can carefully align the border of the drawing to the Tsquare and fasten the drawing paper to my drawing surface. Next, I'll demonstrate using triangles together with a Tsquare. And there are two common sizes of triangles. There's a triangle that has a 90-degree angle, this so-called right angle, and together with two 45-degree angles. And then there's another triangle that has a 90-degree angle, together with a 60-degree angle and a 30-degree angle. It turns out in engineering drawings that these angles, 90, 45, 30, and 60, are very common. We can make all the horizontal lines on the drawing with the top edge of the Tsquare itself. I'm keeping the head of the Tsquare tight against the left edge of the drawing board so that as I move it up and down, that top drawing ruling edge, as they would call it, this is the ruling edge of the Tsquare, that edge of the Tsquare stays horizontal and makes parallel lines. Let me make a couple. Remember, I'm now using the uniform thickness lead holder, and so I want to hold it perpendicular to the paper. Now, if I want to make lines that are exactly at a 90-degree angle to that, I can use the 90-degree angle on either the 45 or the 30-60 triangle. And now what I'll do is I'll keep the, over on that end, I'll keep the head of the Tsquare tight against the edge of the drawing board with one hand, and with the other hand, I'll keep the one edge of the triangle against the top edge of the Tsquare, and with the other hand, I'll hold the pencil, and with the other hand, I'll hold the triangle. Wait a minute, ran out of hands. What you have to do is develop a little dexterity. So your hands have to do double duty. I'm going to keep pressure in that direction to keep this Tsquare tight against the edge. I'll use the same hands, the fingers on the same hand, to slide the triangle, keeping pressure against the top edge so that that'll make a nice, perfect right angle. I'll hold that tight in place, and then keeping my pencil at the proper angle, I can draw lines that are exactly 90 degrees to the horizontal. And these lines are, of course, called vertical lines. Now, with the same triangle, I can draw lines that are at a 45-degree angle and they're a 45-degree angle, it turns out, to either horizontal or vertical because of the nature of the 45-degree angle. I can turn this and draw 45 degrees in the other direction. Or if I have a lot of those to do, I could actually use it this way and do 45 this way, 45 that way. I can also make 90-degree angle lines or vertical lines with the 30-60 oriented either way. Or I can make angles at a 30-degree angle. I could make lines at a 30-degree angle to the horizontal in this direction, a 30-degree angle to the horizontal in that direction, 60-degree angle in either direction. I can turn it this way. I can make, here's 60, here's 30, here's 90. So you can make a lot of different lines with these triangles. And notice by sliding this along, I can make a whole series of lines that are exactly parallel to each other by sliding and drawing. And if I was doing something you'll see later called cross-hatching, you'll do this a lot because you'll be making a whole series of parallel lines. Parallel lines all have the same angle. Now, what if you need angles other than 45 or 30 or 60? It turns out you can use a combination of these two triangles and get angles in 15-degree increments. If I add 30 degrees to 45 degrees, for example, that'll give me what? Let's see, 35, 75. Or in the other direction, I can get lines that are actually 15 degrees from the horizontal. Or I can use the 45 together with the 60. As a matter of fact, I'm going to show you an illustration on the screen that was generated by computer that shows you all the combinations of angles you can get with these two triangles. That illustration, by the way, is also found in your Engineering Drawing 100 workbook. Here we have a computerized illustration of the use of the different triangles. You'll see that with a 30-degree triangle, you can make 90-degree angles. You can make 30 degree from the vertical. You can make 120 degrees from the horizontal. On this other side, we have 60 degrees from the horizontal. Then if we lay the triangle, the 30-60 this is, in the other orientation, we can make 30 degrees from the horizontal. That also happens to be 60 from the vertical, or 150 degrees from the horizontal on this side. You remember from math class that this small acute angle is called an acute angle, and this big angle is an obtuse angle. And you might also remember from math class that one straight line adds up to 180 degrees of angle. So if we add 30 and 150, we get 180 degrees. In this case, if we add 60 and 120, 180 degrees, just like the math teachers tell us. Let's look at the 45-degree angle. Again, the 45-degree triangle can be used to make 90-degree angles. That is 90 degrees from the horizontal. We can draw vertical lines. We can also get 45 degrees from the vertical, 135 degrees from the horizontal, or 45 degrees from the horizontal. Then we also have the option of combining the 45 and 60-30 triangles. In this orientation, you'll notice that by putting the 30-degree angle in here and laying the 45-degree triangle this way, we can actually make 15 degrees from the horizontal. We orient them slightly different, and we can add the 30 into 45 and get 75 degrees. Or we twist them around another way, we can get 105 degrees, or yet another way, 165 degrees. If you keep playing around with these two triangles, the 30, 60, and 45, you'll find that you can make any 15-degree increment angle that you like. Well, now you've seen how we can make lines that are horizontal or vertical or 90 degrees to each other. You've seen how we can make lines at 45 or 30 or 60, or even by using the combination of two triangles at any increment of 15 degrees. But there must be lines at angles other than increments of 15 or 30 or 45. Question is, I've drawn a couple of lines here. The question is, what's the angle between those lines? And the answer is we have to use a protractor. You might have used one of these in math class already. What we do is there's a little target here, and we set that little target right at the intersection of the two lines. Then we align the edge of the protractor with one of the lines, and then we read the angle between the two lines on the edge of the protractor. Now you want to be careful because this protractor has two sets of numbers. It starts at 0 here and goes around clockwise to 180, and it starts at 0 on the outside set of numbers and goes counterclockwise to 180. And when you're looking at these numbers, make sure that you get the right number. In this case, this angle is about 30, I'm starting at 0, 10, 20, 30, about 34 degrees. Coming around the other direction, I start at 0, 10, 20, 30, 40, 146 degrees. So depending on whether you want the cute little angle in here or the obtuse angle, you need to know which side of the protractor to use. You can also use this protractor to construct lines at any angle. Suppose that I wanted to construct a line that was at a 53-degree angle from the starting line. Well, in that case, I'd follow around here, 10, 20, 30, 40. I know this is a little small on the video screen, trust me. 10, 20, 30, 40, 50, 51, 52, 53, and I make a little mark here at 53, and then I take one of my triangles and I carefully draw a line from the intersection point through that little mark I made, and I have a line that's actually a 53-degree angle in this case from my starting line. I'll just sketch in a little dimension there. Here's a little closer view of the protractor. And if you look close, you can see this little target area. It's almost like a reverse magnifying glass, and it has a thin line scribed there so that I can point exactly to the intersecting point to line that up. And then you'll notice here the double scale. The inside one starting at 0 going one way, the outside one starting at 180 and going downhill. So again, be careful whether you use the innie or the outie when you're measuring the angle. Always go back to the edge where you've lined it up to and start counting from there, depending on whether you want to measure an acute angle or an obtuse angle. So we can construct lines at any angle using the protractor. But if you have a little more money in your budget, there's another way to do it. You can use something called an adjustable triangle. Now this triangle starts out with a 90-degree angle and a 45-degree angle, but it has this little thumb screw that you can loosen it up, and then you can adjust this. And there's a little built-in partial protractor right there. So if I want to make an angle here with the horizontal, I can adjust this until the reading on my mini protractor is what I want. Set this, slide it to the point that I want, and make lines at that angle. You notice though that this only goes from 45 on up to 90. What if you want to make angles that are smaller? Well, you can turn it around and you can swing it this way, or you can use this side over here. Once again, when I slide this all the way down tight, this side over here will be at 45 degrees, and that's what this dial indicator says. Now when I slide this out, I can use a little mini protractor to adjust this, tighten the screw, and then draw lines at the desired angle. Before you get too far into your drawing career, you'll have to start adding words to your drawing. And since the words communicate technical information, the lettering in your words has to be very precise and neat. And you'll want to make guidelines so that your lettering will be of uniform height. And this is one way to do it. This is called an Ames lettering guide, and it has a bunch of little holes in here. So I'm going to have to use my conical point pencil, sharpened pretty sharp, and it has this center circle, which if I grab it, I can adjust it. And when you get yours up close, you'll see there are little marks on there that I can use to adjust this to. By the way, each one of these marks is an indication of a different lettering height. And once I get it adjusted to the size that I want, it'll stay pretty much steady there in that little circle. Now, you'll find that there are different sets of holes. Some of them are evenly spaced, Some have big spaces and small spaces. Some people like to have tall letters but shorter spaces in between the lines of lettering, and that's what they use those alternate sizes for. Some people like to have a uniform spacing of guidelines with the same amount of space between rows of letters as the height of the letters. Now, the way this is used, again, I use a conical point pencil, usually with a very hard lead, because these are going to only be guidelines. The thing about a guideline is it should be so light that you're the only person who can see it, and when you make a copy of your drawing, it will not copy. I'm going to make these a little darker than usual just for the video. The way I use this is I put the pencil in one of these holes, and then I run it across the paper, then I move it to the next hole, run it back again, and you can see it's made parallel lines nicely spaced. Then if I go off someplace else in the drawing and repeat that process, you can see again these lines are the same spacing. Now, again, I've made these darker than they should be. When you do this so light that if you're an arm's length away and you squint just a smidgen, you cannot see these lines because they're guidelines for lettering. And then when you get ready to do some lettering, you'll, with your very firm stroke, you'll go in and you'll letter using those guidelines, and you'll probably use uppercase block Gothic lettering for the letters you add to the drawing. In this brief introduction to the use of drawing instruments, you've taken a look at different kinds of pencils for making lines. We've made lines with triangles at different angles. We've used a T-square to make horizontal lines. We also used a T-square to align up the paper so that all the lines would be aligned with the border line of the paper, not the edge of the paper. You've also seen how to use a lettering guide to make equally spaced construction lines to add words or text to drawings. Well, this is just the beginning. In the next videotape, we'll explore more of the drawing instruments used for making engineering drawings.